Hey, welcome back. My name is Matthew. Today we're going to cover a little bit more ggplot. So we're continuing with the Intro to ggplot tutorial series. This is episode 3. Last time we made a pretty nice plot, but our methods were not the best. So we're going to be covering a few things today. I'll show you how to set a default theme so that when you are making your plots, you can change your themes all at once just by changing one line of code. And that way when you render your plots, you don't have to worry too much about what theme you're using, and you can change it later on when you decide what you really want. We're also going to try reducing the redundancy in our code. In our last tutorial, we had several calls to geomLine and several calls to geomPoint. What we really want is to only call each of those one time. There may be situations where you have to call them more than once, but it's better to put everything into one data frame and then let ggplot handle the separations. So you can plot many lines at once from one data frame. And that's what we're going to be doing. A byproduct of doing things this way is that it makes it much easier to add informative legends. So I'm going to show you how to add a legend to the plot. I'm going to show you how to customize the legend, and how to hide any guides and things like that you don't want. And of course, the default text for the legend isn't going to be the prettiest, so I'll show you how to set the text to whatever you want it to be. Alright, enough with the introduction, let's get going. So, we are going to start where we left off last time. First we need to load the ggplot2 library. We're again using the ms-sleep dataset from the ggplot2 package. Alright, so we've combined the data cleaning into one line, so we can just run that. And all of this is stuff that we did in the last tutorial, so you can check that out if you want to know what any of this does. But essentially, we're just setting up all of the data so that we can run this one giant plot. As you can see here, we have one call to geomRibbon, and we have 3 calls to geomLine, and 2 calls to geomPoint. Now we want to collapse these down so that we have 1 call to geomLine and 1 call to geomPoint. So that's our goal. That's what we're going to do. First, let's take a quick look at the plot, because we want to make the plot essentially the same. We're just going to use more efficient methods. Oh, you can see there's something different here, and that's because I have put this in the wrong spot. So let's move that out. There we go. So we've got our outliers in red, we've got all of our other data points, we've got a regression line, we've got our upper and lower standard error bounds. Looks good to me. So what are we going to do? Well, before we make any changes to the plot, I'm going to show you how to set a default theme. So right now we have theme BW, black, white, but let's suppose that we wanted to change it to a different theme. So let's say we want to use the classic theme. Well, I'll run that again and I'll show you what that looks like. So you can see we've got the same plot, but it looks totally different. We've lost the hashed background, we don't have a full box. When you change the theme, your plot is the same, but all of the theme components change. Now I'm going to put this back to black and white, because this is what we had before. Now, if you want to set a theme for all of your future plots, you go theme _ set, and then you just type in the theme that you want. Now, I'm going to go theme _ I'm just going to quickly show you. We've been using black and white. Classic is another one. There are loads and loads that you can choose from, and you can get more themes online, or you can create your own themes. It's not super difficult, but we're going to set our default to classic. So Control Enter. Oh, and I'm missing, so you see here, when you run a function and you don't have the curly braces on the end, it prints out the contents of the function. So what I was missing there are these parentheses. So we'll try that again. Control Enter. There we go. Theme set to theme classic. Now, if we want to make use of that, I'm just going to copy and paste this code so it's identical. So here we've set the theme. Now I'm going to change theme black and white to theme get. Theme get will get whatever our theme was set to. So previously we used theme black white. Now theme get, it's going to get theme classic. So let's control enter and let's print this off. So you can see our theme has changed. All right. So now that we've set our theme, let's move on to updating our methods. So we want to collapse these geom_points into one geom_point call. All right, so first of all, what does our data look like? So let's take a look at the head of our data clean. So you can see here we have a column that is log BW and a column that is ST. So total sleep time and log of brain weight. Let's also take a look at what we have for our data outliers. So you can see we have the exact same columns, so that's going to make it very easy to combine these. But when we combine them, we want to keep track of which data set they belonged to. So we're going to add an extra column to each of these. So here we're creating a new data frame. We'll call it all points data. So we're calling data frame. We're taking our previous clean data and we're adding a new column. We're calling that column type, and we're just going to give it the value all for every row. So let's run that, and let me just quickly show you what that looks like. So you can see we still have our log of the brain weight, we still have our total sleep time, and now we have this new column called type, and for every row it's filled with all. Now we want to do the very same thing with our data outs. Okay, so we're putting that into out points data. It's exactly the same as before. We're taking our data outs data frame and we're adding a new column. We're giving it the same name. This is important because we're going to be combining these two together. So type equals all for our all points, and type equals out for our outliers. Now let's combine them together. To do that, we're going to use rbind. Now rbind takes the rows from the first data set and adds them to the rows from the second data set. So they're getting added on top of each other row-wise. And let's look at the bottom of that data set with the tail function. So you can see we have, going all the way to the bottom, we have our all, because there are lots and lots of data points in all. And then we have our two outliers at the bottom. So type tells us whether it's an outlier or not. And other than that, they have the same type of data. All right, so we're just going to copy and paste this, and I'll show you how to modify it to make use of these new data. We're going to save this into G2. And now we're going to completely get rid of this line here. So we only want one call to geom_point. So let's get rid of this. We're going to use our new data set, which we have called point data, because we're going to be plotting it with geom_point. Now our aesthetics are going to stay the same because we still have ST and log BW as columns. But now we're going to differentiate the points by whether they're outliers or not. So we're going to have color is equal to type and alpha is equal to type. So we're going to have to get rid of this because we're now moving it inside of the aesthetics. It's no longer a uniform value to apply to everything. It's going to be applied depending on type. Now when we do this, you may notice that we aren't telling it what color or what alpha to use. It's going to take care of that on its own. Later on, I will show you how to set the colors and the alpha that you want to have. Now let's give this a run and see what happened. So we run it, and now I will print it to the screen. So you can see very faintly we have those normal points and those outliers. The colors and the alpha are not at all what we want, but we'll deal with that later. For now, it's important just to see that all the points have been plotted, and they have different aesthetics depending on whether they fell under the all category or the outlier category. As well, we now have a legend, and that is because we have assigned aesthetics other than position inside here. So these aesthetics, color and alpha, are now showing up in the legend. So you can see what the color and the alpha are, and the label is type, which just comes from this right here. Later on, I'll show you how to change these text values, but for now, let's move on and try to collapse down our geom lines into a single geom line call. So we are going to leave this plot here because we're going to be continuing to work off of it. We're going to add up here another data frame because we want to collapse all of our data here into one. So this is all coming from data mod 1, which is our fitted model data. So just like before, we're going to create a new data frame, and we're adding a new column. Again, we're going to call it type, but you can call it whatever you want as long as it's the same for each of the data sets that you want to join together. And we're going to label this as regression. So first, we're taking all of the data for the regression line. We're putting into the data frame reg line data. And you probably want to see what that looks like. So let's look at the head. And you can see down here, we have our X values and our Y fitted values. And now we have the type column where we've labeled it as the regression. Okay, now we're going to add the upper standard error. So to do that, we have to do it a little bit differently because we want to modify one of the columns. So we're going to take the X column and put it into the variable X. And we're going to take the Y fitted column and we're going to add sigma to it. So remember, this is our standard deviation. And that's going to be we're still going to call it Y fit, but it's slightly different because this is the Y fit plus sigma. And we're going to call it the upper standard error. We're going to do the exact same thing for the lower standard error. The only difference is that we have subtracted sigma instead of adding sigma, and we've changed the type to be lower standard error instead of upper. Finally, we're going to, just like we did with the point data, we're going to have a all line data, and we are going to R-bind these three together. So we now have one single data frame with all of our line data in it. Let's take a quick look at what that's like. So we're going to do both the head and the tail, so you can see the top and the bottom. Of course, it would help if I ran these. So I got these errors because I didn't actually run this, so none of my data frames were created. There we go. Now we'll look at the head and the tail. And I'll make this just a little bit bigger for you. All right, so the head, we have our X values, our Y fitted, and you can see that it's still in order. So we have our regressions on the top, on the bottom, or the tail, we have our lower standard errors, and somewhere in the middle are the upper standard errors. And that's just because of the order that we did the R-bind in. See, the lower standard errors are on the bottom, the regression line is at the top. Okay, so now that we've done that, we're going to go back down to our ggplot call, and we want to compress all of these geom lines into a single geom line call. So let's delete these two extra calls. Now we only have the one, but our data is no longer data mod 1. We're going to use all line data. Our aesthetics are the same. We have our X is X, Y is Y fit. And what's changing is we're going to set our line type equal to type. And we're going to set size equal to type. And while I'm at it, I see that I forgot to to set size equal to type for our geom points. So let's do that right now. Okay, now let's run this and see what we get. Let's print G2 to the screen. And you can see that we still have all of our lines. Here's our regression line. Here's our lower standard error. Here's our upper standard error. You can see we have different sizes on the points now because we added that right in here. Now this is starting to look really ugly, and that's because we're letting ggplot choose what the aesthetics look like. So what we're going to need to do now is add some manual scales, which will allow us to set what these values are. Okay, so for every aesthetic, there is something called a scale. So we are going to start by modifying the scale color. Now there are lots of different ways to do this, but we're going to do it the manual way, which means that we get to set what the values are. So here is where we set the colors. So we do it just like we would have before. We type in the colors, say blue and red, although I think we want black and red. Now what's really nice here is we can give these names, and those names will match with the type. So because we've assigned color to type, the different values of type can be names that we assign here. So we want black to go to our all type. So all equals black. And we want our outliers to be red. Now when we print this out, you can see that our outliers are red. Now because of the alpha, you might have some trouble seeing it, but our alls are black. And since we don't want our alls to be nearly invisible, let's do another scale. This one is for alpha, and again we'll use manual. We want our all to be 25% visible, and we want our out to be 100% visible. Alright, running it again so you can see how the alpha has changed. So you see that you can see the all points a little bit better. I think 25% is probably not enough. Let's change it to 50%. There we go. Now we can see the points, but they're not jumping out too much. And our outliers, there we go. We also want to change the size. However, we have assigned a size to both the geom points and to the geom lines. Now what that means is that we can assign values for all of them at once. So we'll go scale, size, again manual because we want to set it ourselves. So you can see that for size, we've set values for all, for out, so those are those two there. But we've also set it for the regression line, our lower standard error line, and our upper standard error line. So we can set all of the sizes at once. Now let's run that and see how the sizes look. Everything is much smaller. Everything is fitting on there pretty nicely. Now we want to change the line type. So let's add that in right here. It's the same as before. Scale, line type, manual. So we'll set regression to 1. Lower standard error to 2. And upper standard error to 2. Now that should give us a normal line for the regression and 2 dashed lines for the lower and upper. So let's run that, and we should see, there we go. So our lines have been updated. All right, and looking at this, it looks like our line type, or sorry, our line size didn't change when we set it in here. The reason for that is because I made a mistake. Now, if we look back up to our geom line call, you can see that I've set the size here outside of the aesthetics. So when you set the size inside of the aesthetics, it allows you to do all of this scale stuff. But if you set it outside, this overrides anything in here. So we need to remove this line, and now the lines should update properly. There we go. Now we have different sizes, and you can see that our legend is starting to get really ugly, and we probably don't want all of this showing up. So let me show you an easy way to get rid of an individual category in here. So we don't want this one, and we got that from this scale size manual. The easy way to get rid of it is just to add a little guides equal false. Now when we, guide equals false. So when we run this, you can see that the guide still exists, as in the sizes have been applied, but it no longer shows up in the legend. So you can very easily remove a specific scale from your legend by doing this. Alright, now let's suppose that we only want to show the point information, and we don't want to show the line information on our legend. That's very easy to do. So we want to get rid of all of the information on the legend to do with the lines. So in our geom line, we just have to add show.legend equals false. And now that will get rid of all of the legend information to do with the lines. There we go. So everything on the plot has stayed the same, but our legend now only has the point data. But this looks fairly ugly. Let's suppose we want to change the legend's title from type, and we want to change these labels as well, so they're a little more informative. This here is contained in the scale color and the scale alpha, so we need to give those both the same information. So we change the title with name. So name equals, and let's say we want it to be point type. Now, if we were to just run this, you'll see that it does something a little bit funky. It splits our points into just color and just alpha, and that's because we've given it a different name here than it has here. So let's just copy this over so we have the same name for both of our scales. Alright, now you can see that it has combined them back together because they share the same title and because they share the same label. To change the labels, we have to do something very similar. We go back to our scale and we add one more parameter, labels. So we're going to say non-outlier, and the red ones are outliers. And we have to have this for both of our scales if we don't want them to be separated out like before. Alright, so you can see under our point type we have non-outliers and outliers. Okay, so I think this will conclude the tutorial. We've been going for a little while now. If there's anything else you want to learn about or anything that you're confused about, feel free to leave a comment down below. Otherwise, I'll see you all in the next video.